So in the next classes, until the end of this semester, I will not repeat these notations anymore. It is your responsibility to remember all of them, right? So anytime I say X bar, you need to know it is sample mean. Anytime I say the mu, you need to know it is the population mean. Anytime I say S, you say sample standard deviation, right? The sigma is the population standard deviation. P hat, sample proportion. The P without hat will be the population proportion. The small n is the sample size. The big N is the population size. Right? So practice a lot so that you need to remember these notations for the sample and for the population. All right, so now let's talk about the sampling distribution. Let's review the idea of the sampling distribution. Right, so suppose we have a population here. Right, so I have a big population here. All right, I want to study about the population. I want to learn some information about the population. But in the real life, we do not have enough time, right? We do not have enough money to collect the information from every object in the population. So what we do, we randomly select a sample from the population. Say it is the sample 1. All right, and then with this sample 1, I can calculate the sample mean X bar. We call it is X bar 1. We can calculate the proportion. We call it is P1, P hat 1. All right, and then we say the sample 1 has the sample size N. So with the same sample size, we keep selecting the samples with the same sample size. So we have another sample, sample 2 from the population. I have another sample. We call it sample 3. And we keep doing so in the population until we have all possible samples. So that we have sample 2. We have sample 3, and so on. All right, and then for sample 2, I can still calculate the sample mean. We call it X bar 2. I can still calculate the sample proportion, which is P hat 2. For the sample 3, similarly, X bar 3, P hat 3, and so on. All right, so now I collect all possible samples. I want to learn that what are these values distributed so that I can learn the relationship between the sample and the population. Right, then we will talk about the sampling distribution. For example, for the list of the sample means, these are possible sample means. Based on these values, I can draw the histogram, right? And then based on this histogram, I can draw the overall curve based on the histogram. And then this curve is actually our distribution. So this distribution is based on what? This distribution is based on all of these sample means. So this is the distribution of sample means, or we call it is sampling distribution of mean. All right, okay, so this is about the mean. Similarly, what if I consider this list the P hat sample proportion? That means I can still have the histograms, right? And then based on the histogram, I can still draw the curve. I have another distribution, but this distribution is based on the sample proportions. So it is the distribution of sample proportion, or we call it is the sampling distribution of proportion. All right, so based on the sampling distribution, we can learn the relationship between the sample and the population. We want to use the sampling distribution so that we can use the sample to estimate the population. All right, so this is where these sampling distributions come from. And now let's come back to the definition of the sampling distribution. It is the distribution of any sample statistic from all possible samples of a given sample size called sampling distribution. All right, so this is the distribution of a sample statistics from all possible samples with the given sample size. And then this sampling distribution, if it is about the mean, then it is called the distribution of sample mean. If it is about the sample proportion, then it is called the distribution of sample proportion, right? Or we call them sampling distribution of proportion or the sampling distribution of mean. Got idea now? All right, okay, now once we have a sampling distribution, we want to know what does it looks like or where these values focus on. All right, so maybe this distribution is normally distributed. Perfect. All right. Maybe this distribution is skewed, not symmetric. Or this distribution may have some long or large outliers or small outliers. We never know about it. But we want to study a special case that if this sampling distribution follows a normal distribution, then we can do a lot of things, right? If it is a normal distribution, then we can go to the standard normal table, right? And then we can find the probability to the left or to the right. We can do a lot of things. We can get the confidence intervals. We can do the hypothesis test. All these things based on only when the sampling distribution is a normal distribution. And then next we want to talk about is for what case these sampling distributions will follow a normal distribution. We want to check whether it will follow a normal distribution. All right, and then let's talk about the sampling distribution of proportion first. Right, that means if I look at this list and they me a histogram, and based on the histogram, I can draw the distribution. All right, we want to check whether this distribution follows a normal distribution or not. And here we have two assumptions to be checked. The first assumption is called the independence assumption. Another one is called the normality assumption. All right, so what is an independence assumption? We say when we select a sample, we want the objects in the sample are all independent of each other. For example, if I select, let's say select 10 citizens from all United States citizens as my sample, I do not want them all from the same family. Then they are all dependent. They are not independent. That means this sample is not representative of the whole population, right? So here, to make sure the objects in the sample should be independent of each other. So how you can make sure that? You need to check the following two things. The first one, the sample must be randomly selected. Right. The second one, the 10% condition should be met. What is this 10% condition? We say we need to control the sample cannot be too large it needs to be less than 10% of the population size. Right. For example, if my population is just 40 students, if I select 30 of them as my sample, then there will be a problem. Some of them in my sample are friends. Some of them are from the same major. Some of them may take previous the same course, something like that, right? So they will not be independent of each other. So in this case, we need to control that the sample will not be too large. It should be less than 10% of the population size. So this is called the 10% condition. The sample cannot be too large. All right, okay, so this is the independence assumption. Next one, the normality assumption. This assumption will make sure that the sampling distribution of proportion will follow a normal distribution. Right? How we can make sure that? We can either check the success failure condition or check number of successes or number of failures in the sample. Right, so the relationship is either or. Let's talk about the first one, the first option, right? Success and failure condition. Here, what you need to check is we need to make sure the sample size n times the p. What is a p again? Without hat, it will be the population proportion, right? So the n is the sample size times the population proportion. All right, so we use the sample size times the population proportion and the sample size times 1 minus the population proportion. Both of these should be larger or equals to 10. The normality assumption will be checked. Right? Why we have another option? Because sometimes the P, which is the population proportion, is unknown or not given to you. Then you may not be able to use this option to check the normality assumption. Instead, you will use this option. We can check that whether there are at least 10 successes and at least 10 failures in the sample. So once we select the sample, we need to make sure at least 10 successes and at least 10 failures in the sample. That means your sample cannot be too small. If the sample is too small, like what I said, I selected 10 out of the whole United States citizens, then the sample is too small. This sample is not representative of the whole population. Right? Okay, so if the independence assumption checked, normality assumption checked, then we can make sure that this sampling distribution of proportion will follow a normal distribution. So this is the first property based on the assumption. Say if these two assumptions are both satisfied, then the sampling distribution of proportion is approximately normal. We just for short, right? So then this sampling distribution of proportion is normally distributed. The larger sample size you have, the sampling distribution will be closer to an exact normal distribution. The sample size, the larger the better, but it cannot be too large, right? Okay, so once we have a normal distribution, remember, anytime we have a normal distribution, we always need to describe this distribution by its mean and standard deviation. These two are the two parameters of a normal distribution. So once we have a normal distribution here, next step will be what is the mean of this normal distribution? We say the mean of the distribution of sample proportion. We have already know this distribution is already follow a normal distribution, right? So the mean of this normal distribution is just the population proportion. Right, the mean of this normal distribution will just be the population proportion P. Next parameter, the standard deviation of this normal distribution will equals to square root of P times Q over N. Right, the population proportion times 1 minus the population proportion divided by the sample size. All right, now we have all of these three properties together, combined together, so that we have this shortcut. Right, we say once these two assumptions are both satisfied, then the sampling distribution of proportion will follow a normal distribution. Two parameters. The mean is just the population proportion P. Standard deviation will be the square root of PQ over N. All right, so now we have complete information about a normal distribution. Then we can calculate the z-score. We can use the z-score to find the corresponding probabilities. We will talk about this later. All right, so here will be the properties of the sampling distribution of proportion. We say we have two assumptions so that we can check whether this sampling distribution of proportion follows a normal distribution or not. If it follows a normal distribution, we need to describe the mean of it, the standard deviation of it. Right. Similarly, we will talk about the properties of sampling distribution of mean. Now we are talking about the mean, not the proportion anymore. Right? We are talking about this sampling distribution, right? Based on all the possible sample means. Right. So now, again, we still want to check whether this distribution is normally distributed or not, right? So again, we still need to check these two assumptions: independence assumption, normality assumption. For independence assumption, you will be checking the same thing. You need to be sure the sample is randomly selected, and also your sample cannot be too large. Your sample size should be less than 10% of the population size. Right? So for the independence assumption will be the same. The difference is the second assumption, normality assumption. Okay, remember when we talk about the sampling distribution of proportion, when we talk about sampling distribution of proportion, we say we check the number of successes, number of failures in the sample. Because we have how many successes, how many failures, so that we can calculate the proportion of success or proportion of failures. But now, what if my sample statistic is the sample mean? They are all values. There are no successes or failures that I can check. Right? They are all numbers. Then we need to change the way to check the normality assumption. And here we will use a very famous theorem. We call it is the central limit theorem. All right, so what is this theorem? This theorem say the distribution of sample mean is approximately normal when the sample size n is large enough. How large is large enough? larger equals to 30 will be considered as large enough. The other way, that means if the sample size n is larger equals to 30, we can always apply this central limit theorem to say the sampling distribution of mean follows a normal distribution. It is easier than the last one. When we check the sampling distribution of proportion, what we need to check is just the sample size. Right? Okay. And then for the central limit theorem, we have some details to talk about. Right? The first one, this central limit theorem is true regardless the shape of the population distribution. Right? So that means the first thing, if the population is normally distributed, if the population itself follows the normal distribution, then the sampling distribution of mean also normally distributed, regardless the sample size. It doesn't matter what is your sample size. Your sample size is 2, your sample size is 4, your sample size is 200. As long as your population is normally distributed, your sampling distribution is always normal. Why? Remember, our sampling distribution is obtained from the population. So if the population itself is already normally distributed, then the sampling distribution is also normal. The other way, if the population is not normal, the population is skewed distributed, then you need to be careful. You have two cases. You need to care about the sample size. If the sample size is larger than 30, that means we can apply the central limit theorem so that the sampling distribution is also normal. The other way, if the sample size is less than 30, we cannot apply the central limit theorem. Then we do not know whether it follows the sampling distribution of mean follows a normal distribution or not. We don't know. It might be, but we do not know. All right, so reversely, for what case this assumption will not be checked? There is only one case that this normality assumption not satisfied. Only when the population is not normal and you have small sample size, then this normality assumption will not be checked. Otherwise, for other cases, this normality assumption will be checked. We can consider the sampling distribution follows a normal distribution. All right, okay. And similarly, we say if both of these two assumptions are satisfied, we will have the following properties, right? We say if it follows a normal distribution, that will be the first property. The sampling distribution is approximately normal. If these two assumptions both satisfied, then this distribution we call sampling distribution, not proportion. Here should be the mean, right? If the above two assumptions both satisfied, then this sampling distribution of mean will be also normal. Right, again, the larger sample size, the sampling distribution is closer to an exact normal distribution. Again, for a normal distribution, we still need to describe its mean, describe its standard deviation. All right, so what is the mean for the sampling distribution of mean? The mean of it, the mean of this normal distribution will be just the population mean. So this is the mean of this normal distribution. What is the standard deviation of this normal distribution? It will be sigma over square root of n. So this is the standard deviation of this normal distribution. All right. Adam, what is sigma again?
Sigma is the standard deviation, correct?
It is the population standard deviation or the sample standard deviation?
It's the population.
Perfect. Thank you. So it is the population standard deviation. All right. Okay, good. So now we have another normal distribution regarding the sampling distribution of mean, and we write it in short for like this, right? So how we pronounce that or how we read this, we say the sampling distribution of mean follows a normal distribution with the mean mu, standard deviation sigma over square root of n, which is the population standard deviation over square root of the sample size. All right.
Can I ask a question?
Sure.
Is the n the number of samples, right, in this case?
You mean this small n?
Yeah.
This small n is the sample size. It's not a number of samples. It's how large is your sample. So how many objects in your sample?
Right.
So like I have 30 students in my sample, so n will be 30. If I select a sample with, let's say, 100 United States citizens, then n will equals to 100. How many
But this
objects?
distribution is of multiple sample means. So we're talking about our n in this case is the amount of sample means that we're talking about, right?
Okay.
That's what I was.
Let's come back to this. All right. So we say how we collected these samples. Still remember? We fixed the sample size, right? When we select the sample 1, we have the sample size n. And then we choose other samples with the same sample size. So we do not have multiple sample size. We only have one sample size. They all have the same sample size n.
Okay, yeah, so it's not the number of samples. Okay, it's that n. Thank you.
Yes. Good question. All right. Okay, so now we say for the sampling distribution of proportion or the sampling distribution of mean, we kind of know how to check whether they follow a normal distribution, and once they follow a normal distribution, what kind of normal distribution we have. And then next, once they follow a normal distribution, we can always have a formula to calculate the z-score. All right, so we have a formula for the z-score if we are talking about the sampling distribution of proportion. So here in this formula, we need to have p hat. We need to know the p. P hat is the sample proportion, right? P is the population proportion. We also need to know the sample size, the size of your sample, how many objects in your sample. All right, and then if we are talking about the sampling distribution of mean, then we have another formula where we need to know the sample mean. We need to know the population mean. We need to know the population standard deviation. We need to know the sample size n. Right, and then once we calculate our z-score, everything changed to easy. We just use the z-score, go to the standard normal table to find the probability to the left or to the right. Okay, so now let's review a little bit for the standard normal table. Okay, so this is the standard normal table. All right, we have the negative part, the positive part. All right, so now let's look at this graph. Right, so we say once we have a normal distribution, once we calculate the z-score from the formula, then this standard normal table will tell you the probability to the left. Similarly, if you have a positive z, yes, Augie? Question?
Yeah, I was just gonna ask, is this PDF on the Canvas?
Yes, this table is on the canvas.
Okay, thank you.
Right, similarly, if your z is positive to the right of 0, right, again, once you have the z, the standard normal table will tell you the probability to the left again. So it doesn't matter your z is negative or positive, this standard normal table tells you what is the probability to the left of your z. What is the probability that is less than your z? Right? So for example, if your z is, let's say, 1.24, what is the left probability? Or what is the probability that is less than 1.24? How you can find that? First, you go search for the z value 1.24. So that means the first digit is 1.2, right? So you have 1.2 here. The second digit, you look for it to the top, so you have 0.04. Now combine these two together. That means this 0.8925 will be the probability to the left of 1.24. This 0.8925 is the probability that is less than 1.24. Got it? All right, now what if my z-score is negative 3.24? Try by yourself. What is the probability to the left of negative 3.24? Davis.
Yes.
Davis? Yes. So what is your answer? What is the probability to the left of negative 3.24?
0.00042 or 0.00060.
Yeah. Good eyes. All right. Thank you. All right. So you need to look for negative 3.2 combined with 0.004, 0.04, right? So that you have 0.0006. Okay, now I changed my question. What is the probability to the right of 1.24? what is the probability to the right of 1.24? Or I can ask, what is the probability that is larger than 1.24?
10.75% or 0.1075.
Perfect. Thank you, Mary. Right. So remember the total area under the curve or the total probability is 1 or 100%. That means if you have the left probability, which is 0.8925, the probability to the right will be 1 minus 0.8925, which is 0.1075. All right, you need to subtract from 1 because whatever you find from this table is the probability to the left. So if you are looking for the right probability, you need to subtract from 1. Aki, yes.
Do you never round up with your z-score, even if it's close to
Yes,
the number?
you need to run your z-score to 2 digits because the standard normal table only provides until 2 digits.
Okay, so if your z-score was 1.29, would you go to 1.3 or would you stay at 1.2?
1.29. So 2 digits is okay. But if you have 1.2856 and so on, you round it to 1.29. You keep 2 digits.
Okay.
Okay, good. All right. So now we kind of done with finding the probabilities based on a sampling distribution of proportion or the probability or the sampling distribution of mean. Now let's do a summary. All right, let me change my screen. All right, so think about what we should do. All right, so first, let's say we want to find the probability, right? So this is our goal. It doesn't matter you want to find the left probability or the right probability. This is our goal to find the probability. Okay, now to find the probability, what do you need? You need to find the probability from the normal table, right? Okay, based on the normal table, what information you need so that you can find the probability? You need a z-score, right? Okay, how you can get the z-score? We have 2 formulas, right? Either z equals to p hat minus p over square root of pq over n. This is for the proportion. Or we have z equals to x bar minus mu sigma over square root of n. This is for the mean, right? So based on these formulas, we can get the z-score. All right. So how we can use this formula? Before we use this formula, what we need to do? We need to make sure the sampling distribution is a normal distribution so that we can calculate the z. How we can check whether they follow a normal distribution? We need to check the assumptions, right? Okay, now reversely. If we want to find the probability to the left or to the right based on the sampling distribution, the first step you need to do, check assumptions. If both assumptions satisfied, then you can calculate the z-score by this formula. And then use this z-score, go to the normal table, find the probability to the left or to the right. right? So this direction is actually when we want to solve a problem, what do we need? But actually when you solve the problem, you need to think or follow the steps reversely, right? So we need to check the assumptions. Okay, so let's just summarize a little bit. We say we have the sampling distribution of proportion. We need to check the assumptions. Still remember what are they? Ethan, what are these assumptions? Ethan?
For the proportion,
Yes, for
the
proportion.
the independence and normality assumptions,
Perfect. So for independence assumption, what do you need to check?
that the sample is randomly selected,
What else?
and the 10% condition.
Perfect. 10% condition. All right. What about the next one, normality assumption? What do you need to check?
The sample size,
We are talking about the proportion, sampling distribution of proportion.
yeah, where the success and failure condition, the
Perfect.
NP is greater than or equal to 10,
Right.
and that stuff.
NP and NQ should be larger equals to 10, right? Perfect. Thank you, Ethan. Yeah. All right. So once we check the assumption, both assumptions are satisfied, then we can calculate the z, right? For the proportion, we have p hat minus p. You don't need to remember these formulas I will give to you. All right. Okay. So we have z calculated. Once we have the z, we can go to the table, find the probability to the left or to the right. Right? So this is about the proportion. Now, what if we want to talk, we care about the mean. We want to find the probability to the left or to the right of one sample mean. The first step, again, assumptions, right? Okay. Sean, can you tell me what are these assumptions?
Make sure that it's randomly selected.
Randomly selected. So this belongs to independent assumption, right? So in the independent assumption, you need to check the randomly selected. Perfect. What else?
Is it the same as the proportion?
Right. So it would be another 10% condition, right? Okay. So let's say for normality assumption, let's say Parker. What do we need to check for the normality assumption if we care about the mean instead of proportion? What do we need to check?
N is greater or equal to 30.
Perfect. Good. Thank you. Right, so we say if the n is larger equals to 30, that means we can apply the central limit theorem to say it is normal, right? Okay, now, once these two assumptions both satisfied, we can calculate the z-score, x bar minus mu sigma over square root of n. All right, and then with the z-score, we go to the table, and then we find the probability to the left. And if we are looking for the probability to the right, we need to subtract from 1. Got it? All right, ready for the example? Let's see. Any questions for now? Any questions? Good? All right, so let's look at this example 1. Consider 400 students as the whole population. Right, so that means what? That means 400 students is my population. And they were asked if they own a car. 240 replied that they did. So we have 240 replied they own a car. Now, suppose you randomly select a sample of 35 responses from the 400 students. Shows as follows. So these ones are yes, that means they own a car. No, that means they do not own a car. All right, what is the probability of selecting another sample with the proportion greater than the one you selected? The one you selected, that means this one, right? Okay, so before we want to follow the steps, we want to think about it, right? Think about this question. We are looking for probability. Then what are the steps? We need to first check the assumptions, right? Before we check the assumptions, we need to decide it is about the proportion or the mean. It is about the sampling distribution of proportion or the sampling distribution of mean. So for this question, it is about proportion or the mean. Joe, what do you think? It's about the mean or the proportion?
The proportion.
The proportion, right? Perfect. All right, so we are looking for the probability of selecting another sample with a proportion greater than the one you selected. Okay, so we need to check the assumptions for proportion. All right, after we check the assumptions, once the assumptions are both satisfied, next step, calculate the z. Right? So we have the formula for the proportion, which is p hat minus p square root of pq over n. So here we need the information of p hat. We need to know, we need to know the population proportion p. We need the sample size n. Right? Okay, now once we have the z, we can go to the table and then find the probability to the left or to the right? Emily,
To
we
the
want
left.
to the left or to the right? We are looking for
Isn't it to the left?
to the left will be the probability that is less than the z we have.
Oh, so to the right.
To the right, right? Because this is our question. We are looking for the probability greater than the one you selected, right? Okay, good. All right, so we are looking for the probability to the right. That means whatever you find from the table, you need to subtract from 1. All right, so now we kind of got the idea about how to solve this problem. We just follow one step by one step. Okay, so check the assumptions. We say for the proportion, we have 2 assumptions, independent, normality. All right, for independent assumption, we need to check whether this sample is randomly selected and the 10% condition. Is this sample randomly selected? Yes. Right? You randomly select a sample of 35 responses, right? So this sample is randomly selected. Good. Next, 10% condition. That means we need to check whether your sample size is less than 10% of the population size. All right, so now, what is this small n? Alex, what is this small n? What is the value for this n? Alex?
I would say the small n is 35.
35, right? Perfect. What is this big N?
400.
400, right? So this 400 is the population size. Thank you, Alex. All right, so now we say N is the sample size, N is 35, whether it is less than 10% of 400? Yes, right? So in this case, this 10% condition is also checked. All right, so independent assumption satisfied. Next one, normality assumption. We are talking about proportion. So for normality assumption, we need to check the successes and failures, right? So either way is okay. If you want to check this way, that means the N sample size is 35. We need to know what is the population proportion. Okay, so in this case, how to get this population proportion? What is the population proportion? Will, what is the population proportion here?
Would it be the population proportion?
Mm-hmm.
I don't know.
The population proportion of owning a car.
Of owning a car?
Yep.
240.
Proportion. 240 out of
400.
Yes. All right. So 240 divided by 400. Within these 400 students, there are 240 of them replies that they own a car. That means the population proportion will be 240 divided by 400, which is 0.6. All right, so in this assumption, that means 35 times this proportion, which is 0.6, equals to 21, which is larger equals to 10. And you need to check another thing, n times q, which is 35 times 1 minus p, which is 0.4, which is 14, larger equals to 10. All right. That means normality assumption is checked. Or if you prefer this way, it is also okay. We want to check at least 10 successes and at least 10 failures in the sample. How we can check that? We have this all responses of 35 responses as my sample, right? So how many yeses? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24. Huh? Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Right? So that means I have 24 yeses. The other 11 of them will be no. Right? So that means I have 24 successes. 11 of them are failures. Both of these two larger equals to 10. All right. So both of these two, either way is okay, depending on your preference or whether the population proportion is given to you. All right. So now the first step is done. All right. Then next step, if it follows a normal distribution, then we can calculate the z-score, right? So the z equals to p hat minus p divided by square root of pq over n. We need the information p hat p n. All right. So what is p hat? How to get the p hat? Sophie?
It's
How-
24 divided by 35, which is 0.686.
Perfect. Thank you. So within these 35 responses, which is my sample, within these 35 responses, I have 24 yeses, right? So that means the sample proportion will be 24 divided by 35. So if you calculate this, p hat is 0.686. All right. Let's say it is 24 out of 35. What is P? We just talked about that, right? Which is the population proportion of owning a car. So which is 240 divided by 400, which is 0.6, right? Okay, what is the sample size? How large is your sample? How many objects in your sample? How many? 35, right? There are 35 responses in your sample. So N is 35. All right, so now plug in all of these values into the formula, you can get your Z calculated as 0.42. All right, so now you have the Z score. Next step, once you have the Z, next step is always goes to normal table. All right, so now let's go to the normal table. We say our Z is 0.42. What is the probability to the left? Josh? What is the probability to the left of 0.42?
Would that be 1 minus 0.6628?
Yes, perfect. Right, so based on the standard normal table, we find 0.42. So this 0.6628 is the probability to the left of 0.42, right? Okay, so now we kind of get the probability to the left, but remember at the beginning, we have already figured out we want the probability to the right. We want the probability greater than the one you selected. That means whatever you find from the normal table, your answer will be subtract from 1, which is 0.3372. Got it? All right, so any questions? Good. All right, so next, another example. Right, according to the Gallup poll, 27% of United States adults have high levels of cholesterol, and this report has been a major concern to health insurance providers. According to the recent studies, cholesterol levels in the healthy United States adults average is about 215, with a standard deviation of about 30. Right. If cholesterol level of a sample of 42 healthy United States adults is taken, what is the probability that the mean cholesterol level of the sample will be less than 200? Okay, let's read the question again. Mark it. What is the probability? So we are looking for the probability. What is the probability that the mean cholesterol level of the sample will be less than 200? Right, think about the steps first. The first thing we are looking for the probability, right? So the first thing, check the assumptions. We need to check the assumptions for the mean or the proportion. Mean, right? So we need to check the assumptions for the mean because we want to find the probability that the mean cholesterol levels. All right, okay, next. Once the assumptions are checked, we can use the formula of z for the mean, which is x bar minus mu sigma over square root of n to calculate the z. Z goes to the normal table to find the probability. Okay, now this question is asking about the left probability or the right probability. Bryce, I see your hand.
Left.
Left, right? Okay. All right. So that means whatever we find from the normal table, we do not need to subtract from 1. Whatever we find from the normal table, that will be our answer. Right? Okay, so now let's just follow these steps to check the assumptions first. Right, so now we need to check the assumptions for the mean. Again, 2 assumptions: independent assumption, normality assumption. All right, the first one, randomly selected. Actually, I miss a random here, so that's otherwise we will stop there, right? Okay, so it is a random sample. That's why it is checked. All right, next, 10% condition. Okay, now we still need to check whether n is less than 10% of the population size. How you can check that? Do we have the sample size? Do we have the sample size? What is the sample size? Augie?
The sample size would be 42.
Right, so sample size is 42. Can you find the population size?
Are you asking me again? No.
No, right? Okay, so in this case, that means we do not have exactly number of the population size. Then how you can check this 10% condition? Because our population size, our population is United States adults. The number, this population size is very, very, very large, right? So that means in this case, 10% of this very, very large number, of course, it is larger than 42. So in this case, we can still check this assumption because 42 is, of course, less than 10% of all United States healthy adults, right? So that means independent assumption checked. The other one, normality assumption, right? So now we are checking the assumptions for the sampling distribution of mean. That means we only need to check one thing, whether n is larger or equals to 30, right? So we say sample size is 42, larger or equals to 30. That means we can apply the central limit theorem so that we can consider it is normally distributed. All right, okay, normality assumption checked. Okay, once these 2 assumptions both checked, next step, just a calculation, right? So we have the Z formula, and then we need to find X bar, we need to find mu, we need to find sigma, we need to find N. All right, so let's come back. X bar, mu, sigma, N. Let's say Brianna, what is X bar?
It's the sample mean.
Then what is the value of X bar? Think about it.
Would it be 42 or?
Okay, so this 42. So let's say if the cholesterol levels of a sample of 42 healthy United States adults is taken. So what is this 42? This is actually the sample size, right? How many of them in your sample, right? So actually this is your N. You just give me the answer of N. Again, what is the sample mean? What is the probability that the mean cholesterol level of the sample will be less than 200? So actually this 200 will be about the sample, right? It will be the mean of the sample.
Okay.
Got it. So here will be 200. This is the key thing. It's the most difficult thing for this question, right? It didn't tell you what is the sample mean, but from the question, it actually, this is the mean you want to compare with. This is the sample mean you want to compare with, right? Okay, so this is 200. Next will be easier, much more easier. All right. Let's say Mary. What is the meal?
Sorry, I was muted. 215.
215, right? Mu is the population mean, right? So this is the mean of the whole population, which is 215. Okay, next. Matthew, what is sigma? What is
30.
30, right? So the sigma is the population standard deviation. So this is the population mean with a standard deviation of 30. That means this 30 is the population standard deviation, right? Okay, now we have all the information here. X bar 200, mu 215, sigma 30, and 42. Just plug in your numbers into the formula. Just calculate your z, which is negative 3.24. Okay, so now you have the z score. Next one, whenever you have the z, you always need to go to normal table, right? So now you have the z equals to negative Okay, so you have z equals to negative 3.24. What is the probability to the left of negative 3 point, is that negative 3.2? Oh, perfect. I think we just had that practice before, right? So negative 3.24. Negative 3.2, focus on this line, combine with 0.04. So we have 0.0006, right? Okay, so this is the value we find from the normal table, right? So that means this 0.0006 is the probability to the left. Do we need to subtract from 1? The answer is no, because the left probability is the one we are looking for, right? So we are looking for probability less than 200. So we are looking for the probability to the left. Then this 0.0006 is our probability. All right, any questions? Good? All right, so then next I want to talk about our assignment. So if you go to the module 1 page, your table, which is the standard normal table, is attached here. I will suggest you to download this table and print this out, right? Because you will need to use this a lot of times. All right, okay. And next, for our assignment, I will suggest you to leave this MyStatLab until next Wednesday. Right. But for today, after today, until next Wednesday, I want you to complete the essay assignment 1 for the first part. You don't need to submit your assignment, just try to complete the first 2 exercises because you still have the fresh memory. All right, okay. So the first one is about the proportion, the second one about the mean. All right, so try to follow the steps to complete these 2. All right, and here I will state my requirements, how you can write on the word. All right, the first thing is when you check the assumptions, you need to list the name of the assumptions, and you also need to state why you check these assumptions. All right, so first, randomly selected, there's nothing to say. Right? If in the question it says randomly selected, then checked. But for the 10% condition, you need to tell me why this 10% condition is checked. Why this 10% condition is satisfied. Give me the reason like this. All right. Okay, so this is about the assumption. Next one, for the calculation of the z-score, I need you to write out the steps, but I will not require you to state this formula. For example, z is calculated by parentheses 200 minus 215, divide by parentheses 30, divide by, okay, here, square root. Right, in your future or in the higher level of courses, you will need to use this SQRT, square root of 42. All right. Okay, so especially in your exam, you still need to write these steps out to get credits. So be familiar with how you write this equation out. Right, and for example, if you want to say X bar, there is no symbol for X bar in the word, then just write as X underscore bar, X bar. For P hat, you can write as P underscore hat.
If we wanted to, like on Word doc, you could, there's like a drawing tool. If we wanted to, could we use that so we can like draw out?
Yes, you can use that, but I think that would be difficult for you to use it in the exam. Right.
Yeah, but I don't know if we can do it in the
Yeah,
exam.
you can use the top list of the words. I just want to show you that what if this kind of question show in the exam what need to do. But in the word, yes, you can. Let's say sigma would be just a sigma. Mu, you can either use U or you can spell it as mu. Right? So just be familiar with this situation. I really don't want to do this, but we have to. All right. Okay. Any other questions? Any concerns right now? Good. All right. So if you don't have any questions, you can leave the room and enjoy the rest of your day. And if you have any questions, just unmute yourself.
Thank